This time I'm going to introduce a purely DIR-based localization method. In some cases, it might work better than AMCL. Let's look at some limitations of AMCL. On the left is the simulation environment where the robot is located. The robot is in the center. On the right is the RVIZ window showing the map. Let's first set the robot's initial position. When we set it manually, it's impossible to be super precise. So there's bound to be some offset, like this. See how the LiDAR points don't align with the obstacles? The robot's position has an error. AMCL is pretty rigid. It stays exactly where you put it, with no intention of correcting the localization. Now let's switch to this pure LiDAR localization method. I'll deliberately create an offset in both position and angle. Look, it automatically corrects itself. Let's try again. It corrects back again. One more time. Finally, let's try something more extreme. See? As long as you place it somewhere near the correct position, it can fix the error. Okay, now let's check out the localization performance during navigation. Let's start with AMCL, setting a navigation goal in the bottom right. Okay, it's moving. Let's simulate what happens when the robot gets bumped or has odometry errors during navigation. Move it a bit. You can see the LiDAR points are clearly misaligned with the obstacles. But AMCL just keeps its original localization regardless. This point, based on AMCL's localization coordinates, the robot thinks it's reached the goal point. But in reality, it's actually ended up on the side table. Let's set another navigation goal point further away. Keep creating localization errors along the way. See that? The error has accumulated too much. Even the detection of dynamic obstacles is clearly misaligned. The navigation path is blocked by dynamic obstacles. The robot can't move. And navigation fails. Now let's switch to the purely DIR localization method. First, navigate to the bottom right. Okay, let us start creating localization errors. Drag it up. You can see this purely DIR localization method automatically detects position changes and quickly corrects the robot's localization errors. Let's try again. See that? Okay, it accurately reached the goal point. Now let's navigate to the top left. Keep creating localization errors along the way. Drag it inside the door. Pull it back. Another accurate arrival at the navigation goal. Alright, so how can you get this navigation method? You can search for GWare on GitHub. Click it. And then follow these steps to download and compile. To make it clear for everyone, I'll quickly demonstrate the process. First, enter your ROS workspace. Use git commands to download the localization algorithm source code. Then compile. Okay, next, modify our navigation launch file to replace AL by misAL launch entry. Some might have it in this node format. Either way, you can replace it with this node. The package name is GWare. Node name is short for LiDAR localization. There are two parameters here. One is the name of the robot-based coordinate frame menu, or DF. Usually a link corresponding to the projection of the robot's base center. The second parameter is the name of the LiDAR coordinate frame menu, or DF. Usually also a link corresponding to where the LiDAR is mounted on the robot, since each robot might have different LiDAR positions on orientations. This parameter is needed to correctly calculate how the LiDAR measurement points are distributed relative to the robot body. Okay, after setting these two parameters, you can run the modified navigation launch file to see how the new localization algorithm works. If you've completed the navigation experiments following my ROS course, you can directly run the test script in GWare. ROS launch GWare LiDAR LOC test. Launch. Enter. Just the simulation window and our VIZ side by side so we can drag the robot around easily. Okay, first test the initial localization correction effect. Then set navigation goal point. Now you can mess with it like we did at the start of the video. If you find this tool useful, feel free to give the project a star like my video. If you run into any issues, you can submit issues or leave comments under this video. Hope you all have fun with it. Follow me for more interesting open source projects in the future. Thanks for watching back.